Alright, Lesson 3, Hydraulic Pressure Limiting, Controlling, and Sensing Devices. Overview, we'll read the lesson description. In lesson, you will learn the basic construction, operation of hydraulic pressure limiting, controlling, and sensing devices. Alright, introduction. Hydraulic system in modern aircraft operates at pressure up to 3,000 psi. The system must be protected against excessively high pressure and cause seals and lines to fail. Pressure relief valves are used to keep the system pressure from exceeding the predetermined safe limit. Complex hydraulic systems can use the number of components, actuators, separate the reversible valve, selector valves, check valves, accumulators, the hydraulic motors. Each of the various components in the one hydraulic system can be operated with the most efficient with the different pressure. In a system having single hydraulic pressure, the pressure producers are using the varying operating pressure to different low components. Hydraulic pressure becomes too low for the safe operation. Hydraulic pressure switch can be used to close electrical current, electrical circuit. The actuating warning light to the cockpit turns on. The secondary system does both. In this chapter, you will learn devices used to limit and control sensing hydraulic pressure. Alright, pressure relief valve. The relief valve installed with any of the system control containing a confined liquid and subject to pressure. For the use of the relief valve falls into one or more 3 categories. First category, relief valve is used to protect the hydraulic system if the pump compensator fails. The relief valve is adjusting opening with the pressure system slightly higher than the normal operating pressure. Second category, the relief valve is used to protect the system subject to pressure and increase the cover of the thermal expansion. In the third category, the relief valve is used as the sole means of pressure control of the hydraulic system. Relief valve. The configuration of relief valves in either 2-port or 4-port. Both types operate in the same way. The main reason for the additional ports convincing of the connection for the plumbing. For simplicity, only 2-port pressure relief valve is described in this text. Your 2-port relief valve. The 2-port relief valve shown in Figure 3.1 consists of the housing of the inlet and outlet port valving device, a compression spring, and adjusting screw. When a hydraulic system is pressurized, the pressure acts over the various valve devices, and this causes the ball is held against the seat and the coil spring. The fluid is pressure is great enough against the ball to overcome the force of the spring. The ball is unseated and allow fluid to pass. The exact pressure into which it takes place in this cranking pressure, the pressure can be adjusted with the desired pressure means with the pressure adjusting screw, fluid passing valve, the ball returns and returning lines back to the reservoir. So it shows the pressure relief device, so the pressure adjusting relief screw, adjusting screw cap, a compression spring, a ball valve device, or pressure port, and a return port. So. Alright, your pressure producer. Pressure producer valve produces the one level of the pressure system of the system. A single hydraulic pump with the producer consists of the 3-port housing, piston, poppet, spring, adjusting screw, spring, and adjusting screw. A poppet valve device, a flat face with 3 ports of the housing, inlet pressure port, reduced pressure port, and return port. So there's 3 parts to your pressure producer: the inlet pressure port, the reducing pressure port, and the return port. Alright, Figure 2.3.2, pressure reducer shows the the input pressure port with a piston, adjusting screw, and then, return port, poppet, spring, poppet, reduce port. Withholding pressure. The pressure reducer operates principle withholding pressure rather than relieving it. With no pressure in the system, the adjusting spring tension holds the poppet open. Withholding pressure. The pressure reducer operates with the principle withholding pressure rather than relieving it. With no pressure in the system, the adjusting spring tension holds the poppet open. As the system pressure builds up, the fluid passes through the top of the reduced pressure port. When the pressure actuating against the piston exceeds the force of the adjusting spring with the principal pressure producer, the poppet moves too close to the inlet port with the further build up. The piston pressure does not affect the reducer pressure until it decreases enough to allow the inlet port to be open and spring tension. Relieving pressure. Pressure reducers relieve the increased pressure resulting from the thermal expansion of the pressure of the reduced with the pressure port. Increase the piston moves against the adjusting spring opening in the return port and relieving the excessive pressure. Pressure switches. Pressure switch is designed to open and close the electrical circuit to respond with a predetermined hydraulic pressure. It activates a warning and protective device at a minimum pressure with the switch can turn on a light, warn a pilot, turn off a pump, actuate a solenoid control, or activate a solenoid control valve. These type of the pressure switches, piston diaphragm, commonly used with the Army aircraft described in the following paragraphs. Piston pressure switch. A piston pressure switch consists of a housing, a cylinder, bore piston, and adjustable spring loading the piston micro switch, linkage of the transmitting movement of the piston to the micro switch housing in the pressure port with the connections to the system pressure electrical receptacle for connecting the switch to an electrical circuit. Alright, this shows your typical piston pressure switch. So there's a pressure port going at an electrical receptacle, micro switch, your adjusting spring, your linkage, and I guess this would be your ground, the black one. So when the piston rises, linkage is a pilot valve to shut off the switch on the electrical circuit. Alright, diaphragm pressure switch. Diaphragm pressure switch consists of the housing diaphragm and adjustable spring loads of the diaphragm micro switch, linkage switching movements to the diaphragm micro switch housing as port. Same function as those of the piston switch. Pressure switch operation. Two types of pressure switches have same operation principle. Only the piston one is covered. The fluid pressure into the pressure port move the face of the pistons against the adjustment spring. When the pressure becomes great enough to overcome the force of the spring, the piston moves the cuff of the pivot lever to rotate. When the movement of the lever is transmitted through the linkage to the micro switch button, close the electrical circuit. Alright, summary. Hydraulic system has a device to protect against excessive pressure. This is called the pressure relief valve. The valve adjustable and set up open to slightly above the maximum string system pressure. The curve of the fluid is returned to the system reservoir. Pressure reducers are used to deliver the correct pressure for each of the component of the hydraulic system, make it possible for one hydraulic pump delivering one set of pressure in a system that requires several different pressures. Pressure switch, a physical combination of hydraulic pressure, pressure port, pistons, and sprint electrical devices, micro switch, and wiring. Pressure switches are used to set its hydraulic pressure depending on the switch. The pressure is high or too low, the micro switch closes and energizes the valve, stops and starts the pump, eliminates a warning light. And then it shows your practice exams, questions, and answers, and then a glossary. And we were going to look up the one that it wanted. I believe it was L. Standpipe is located reservoir when the main hydraulic system draws its fluid. And that completes the book on basic hydraulic systems and components, subcourse AL0926 edition A.